Is it streaming again? It looks like it. Let me check. Alright, so I'm back. Sorry guys, like I said, something's wrong with the online today, so go like this. Bear with me. Alright, so I'm going to go ahead and continue just to finish off and get started with the lesson. So at this point, who notices that we have the same basis here already? 2 and 2. So that means that the exponents should be the same. If they are the same, that means that this is equal to that. So let me write that over here. 6 equals n minus 1. And now we can actually solve for n. So plus 1 plus 1, 7 equals n. So how many terms? Let's see if we answer the question. The question was, given the sequence, write the explicit rule and use the rule to identify the number of terms in the sequence. So how many terms does a sequence have? 7 terms. 7 terms in the sequence. Whew, that took a while. Alright, so with that said, let's get started because it's getting overcast and my light's going to be gone in a little bit. Alright, so our objective, oh my bad, our home plate for tonight is page 663, all only. Page 663, all only. And your Nearpod code is OIFPX. Nearpod code OIFPX. And once again, that's so that you can log on and make sure you get to, when you get to all the windows that have the toolbar underneath, make sure you put the lock on it and take pictures of whatever is asking on the screen. If it's the warm-up, the warm-up. If it's the home play, the home play. If it's the Frere model, make sure you write it in there. Don't take a picture, or unless you did it on paper, that's fine, but try and do those by yourself without looking at your notes. And I want to see the notes on what we do today just to make sure we got it. Alright, so our objective for today, I can graph and write exponential functions. I can graph and write exponential functions. So just to recap from last week, we know what exponential functions are. We don't need to do that. You're going to do that by yourself. We revisited the general form, and we know what the parameters do, a, b, h, and k. And then right there we applied that to our exponential form. A times b to the x minus h, close parentheses, plus k. And then we got to these with a base of 2. We did several of these. We saw what it did. Then we got to these where the base was a fraction, and we saw how that one went downward. So, and what did we say from the 2? That when we got to these, there were 2 types. They were exponential growth and exponential decay. You guys remember that, right? And once again, I left you guys that Desmos activity, so you guys can go back and see that. And also, I had you guys fill this table with all the different things that you saw using Desmos. Alright, and once again, just to revisit that. And now we end up with writing equations given this function. So, on your paper, copy that graph really quick, example number 2, and it reads, write the equation of the function given the graph. And they give us this exponential graph. And they have an asymptote going through positive 2. And they give us 2 reference points in case you don't see it from your screen. This first reference point is at 1/2 of x and 2.5 of y. 1/2 of x, 2.5 of y. The other reference point is at negative 1/2 of x and 3.5 of y. Negative 1/2 of x and 3.5 of y. Copy that, and then I'll go over the example. Man, what a beautiful day. It's a little overcast, and I think it's gonna rain tonight or in the evening. But overall, it looks pretty good. All right, y'all ready? All right, here we go. So this is an exponential function. So to find or to write the equation of this function, we need to start with what? G of x equals a times b, and we have the exponent of x minus h, and then at the end the constant of plus k. All right, so what does that mean? What that means, we need to find b, and we need to find h and k. Let me make some more room over here. All right. So first of all, what do we know about the graph? What does this asymptote represent? It's y equals 2. Y equals 2. We know that this is our k. So let's label that here. This is 2. All right. Next, I want you, whenever you're writing your equation, start with the point closest to the asymptote. So which is our point closest to the asymptote? The point closest to the asymptote is this one right here. So let me label that one. That point we said was at 1/2, comma, and it's what? 2.5. But I'm going to write it in fraction form. From here to here, how many halves do we have? 1, 2, 3, 4, 5 halves. So 1/2 and 5 halves. That's my reference point. All right, so once again, this is our first reference point that's closest to the asymptote. So why do we pick that one? Because now we can actually identify our h. Our h would be this one. So I'm going to write what? 1/2. All right, so now that we have that 1/2, we already have k, we have h. So now we just need to figure out a and b. The easiest one to get started with will be to figure out a, I'm sorry. So we're going to figure out what a is. Let's solve for a. To solve for a, I'm going to use the same reference point, this one, but I'm going to use this second value right here. And I'm going to write what? A plus k. You guys remember this? Yeah? Yes, Mr. Q. All right, good. So therefore, I'm going to write a plus k equals 5 halves. However, do we know what k is? Yeah, it's right there, which is what? 2. So I have a plus 2 equals 5 halves. Okay, so let's solve for a. So what do I do here? I need to get rid of the 2, so I subtract 2. Can I make the 2 into halves? How many halves are in $2? Yeah, 4. So I'm going to subtract 4 halves. Subtract 4 halves from each side. So I'm left with a equals 1/2. So now we have a. All right. Does everybody see what I did there? In case you don't see it, the 2, to make it into halves, I put it over 1. That means I need to multiply times 2 times 2. So this becomes 4 over 2, and that's why I wrote 4 over 2. So I subtract from each side, and that's what I get. All right, so now that we have a, h, and k, what's the only thing we need to solve for? Yeah, that's right, b. So I'm going to write the whole equation, and I'm going to substitute all these values. So here we go. I'm going to write g of x equals, what is a? 1/2 times b. Then we got x minus, what was h? H was I'm going to use green so you guys can see it. 1/2 plus, and what was k? 2. Does everyone see where I got all these values? Yeah. A is right there, it goes right there. H is right there, it goes right there. And K is 2, and there it is. Alright, so now all we need to do is solve for B. How do we do that? Well, we need an X value and a G of X value. But we're not going to use the same point because we already used it. We're going to use the second point. So I'm going to use this second reference point, and let's write the coordinates for that point. What are the coordinates? -1/2, -1/2, and it's 3.5, but I'm going to use halves to write that. 1, 2, 3, 4, 5, 6, 7 halves. So this is our X, and this is our G of X. So let's substitute those values in here. What was G of X? 7 halves equals to 1/2 times B, and then X is -1/2 minus 1/2 plus 2. Alright, so let's simplify. Let's see what we got so far. Now I'm going to switch everything to black. Here it goes. I got 7 halves equals 1/2 times B. What is -1/2 and -1/2? Yeah, that is right. -1 plus 2. Alright, so from here it's just a matter of doing some computation. You guys got plenty of practice last week with the graphing, right? Alright, so here we go. So we need to leave B by itself. We start by getting rid of the 2. So I'm going to subtract 2 from each side. And what did we say 2 was in halves? Yeah, I can change this 2 to what? -4/2. This is this. So what is 7 halves minus 4 halves? Alright, that is correct. We're left with 3 halves equals 1/2 times B to the -1. Let me rewrite this, it's kind of ugly. Alright, so we still need to leave B by itself. So I need to get rid of this half. To get rid of this half, I need to multiply times 2 times 2 times 2. So this is 6/2 equals, this is a giant 1. So we're left with B to the -1. Alright, so what is 6/2? 3. And can we leave B to the -1 power? No, that goes in the denominator. And what goes on top? 1. And I'm not going to write the +1 because we know it's an invisible 1 right here. Alright? So at this point, we're going to put this over 1. Now we have a proportion, cross multiply, 3B. And 1 times 1 is 1. And let's solve for B. Divide by 3, divide by 3. B equals 1/3. 1/3. Alright. So now that we have our all values, now we can write our equation. Let me go back up. This is 1/3. Alright, so here we go. I'm going to rewrite this with all these values. G of X equals, what is A? I'll write it in that color so you guys can see it. 1/2 times, what is B? 1/3 And then we have x minus as the exponent. And what is h? 1/2. And then at the end plus, what is a constant, or what is our k? 2. And that's how we write our function. G of x equals 1/2 times 1/3 base with the exponent of x minus 1/2 plus 2. Piece of cake. So we're like, okay, Mr. Q. Well, it's, like I said, it's just like I said, it's just work. It's got a lot of steps, but it's fairly doable. Let me just go back and double check our steps. Here we go. So we started off with a graph, and then we wrote our general function. G of x equals a times b to the x minus h plus k. So then from there, we needed to identify which values, a, b, h, and k. Now, what do we know that the k was? This is our asymptote. Here it is. So we wrote that here. Where did we get the 1/2? So we went with the first reference point, which is closest to the asymptote, this one, and we wrote the coordinates, and we said the coordinates were 1/2, 5/2. So that's where we get our h. There it is. To solve for a, we wrote a plus k equal to the second value, or the value of that reference point. So we wrote a plus k equals 5/2. We know that k was what? 2. Subtract 2 from each side, but I made it into fraction form, so 4/2. So 5/2 minus 4/2 is 1/2. That's how we get 1/2. Then we get all those three values, we write them in there, and the only thing we needed to solve for was b. And how did we solve for b? We went to our second reference point, which is this one. We wrote the coordinates, -1/2 and 7/2. -1/2 and 7/2. Here it is, -1/2, 7/2. And then we just simplified. -1/2, -1/2 is -1. And from there we subtract 2 from each side, but we made this 2 into halves because 7/2 minus 4/2, it gives us 3/2. And then we need to get rid of this 1/2 here by multiplying times 2 times 2. So this becomes an invisible 1. So 2 times 3 is 6, divided by 2 is 3. We can't have b to the -1, so we send that to the denominator, and it's an invisible exponent of 1 over 1. Cross multiply. So we end up with 3b equals 1. So then divide by 3 both sides, so b equals 1/3. We write that here. We write our equation. And there you go. Alright? Alright, let's see you try one. Here we go. Example 2q. 2q reads, write the equation of the function given the graph. They give us the asymptote of y equals 7. And the reference points given are, they give us the one closest to the asymptote is -2, 4. And the other one is -3. Oh, my bad. -2, 4. And the other one is -3 and 1. Yeah. All right, copy that. I'll give you some time to get started. Give you a head start. Let's see how you do. We'll go over it together. Alright, so what is the first thing you did? Yeah, you need to write the general form. Let me make some space on this side first. Here we go. So I'm going to write what? G of x equals a times b, b to the exponent of x minus h plus k. Which means we need what? A, we need b, we need h, and we need k. So which is the easiest one to find? K, because we know k is the what? The asymptote. Let's look at the asymptote. This dotted line right here, which is what? 7. This is our k, so that goes right there. Alright, next let's look at the point closest to the asymptote. The point close to the asymptote is this one right here. Let's label that. That point is what? It's 1, 2. It's negative 2, 4. Negative 2, 4. And now we know that this is our h. So our h is what? Negative 2. Alright, now that we have that, now we need to figure out a. We use this last part of that same coordinate and we write a plus k. So I write a plus k equals 4. However, instead of k, what was our k? 7. So I'm going to write a plus 7 equals 4 minus 7 minus 7. A equals negative 3. Alright, there it is. So let's take all those values, substitute into the original function. So we end up with g of x equals negative 3 times b x minus, what was h? H was negative 2. Negative 2 plus k, what was k? 7. Alright, I'm going to rewrite it one more time just to simplify here some of the signs. G of x equals negative 3 times b x, what is negative times a negative? Positive 2 plus 7. Alright, so now we just need to solve for b, and how do we do that? We need an x and a g of x, and that's where we go to our second reference point, which is this one. So what are the coordinates for this point? We got negative 1, negative 2, negative 3, and positive 1. So this is our x and this is our g of x. So g of x is 1, and I have negative 3b, and x is negative 3 plus 2 as an exponent, and our constant is plus 7. Alright, let's solve for b. So we subtract 7 from each side. Let me change colors for that. Subtract 7, subtract 7. We end up with negative 6 equals 2. Negative 3 times b to the negative 1 power, because negative 3 plus 2 is negative 1. Alright, let's get rid of this negative 3 that's multiplying, so we divide by negative 3, divide by negative 3. That leaves us with 2 equals b to the negative 1 power. Can we leave the b to the negative 1 power? No, which means we need to rewrite it. We send b to the negative 1 to the denominator. It becomes a positive 1 power. I'm not going to write it, but it's over 1, and that is equal to 2. Alright, let's make this into a fraction. So like that we have a proportion. What is 2 times b? 2b. What is 1 times 1? 1. And we solve for b. So what do? Divide by 2, divide by 2. b equals 1/2. How you doing, Ben? Let me finish this up. I can probably answer that later. So here we go. We got b equals 1/2. So, let me write 1/2 right here. And now we can write our function. So let's see. G of x equals let me write with the same colors, -3 for a times, what was b? 1/2. Then we got x minus, but what is h? -2. And then at the end, plus 7. All right, let's simplify this. G of x equals -3 times 1/2. Then negative times the negative is a positive, so it's x plus 2 as an exponent, and then plus 7. And that's the function for that graph. All right. Pretty simple process, yeah. It's just like extensive as you're going through the function, but it's doable. All right, let's see how you do with one by yourself. This one completely by yourself. Example 2, super cute. And once again, it reads, write the equation of the function given the graph. So we got an asymptote of 3, and the function given, the reference point closest to the asymptote is -2, 4, and the second reference point is -3, 7. All right, guys. Well, once again, it's just your home plate is going to be just a couple of problems like these to write. I'll leave this one for you to practice on your own, just to make sure that you have the extra time or the extra practice. And on Thursday, we're going to finish up with just applying what we know now to real world problems, and you're going to see how it really applies to what's going on around us right now. And we're going to actually write a function given some data. So if you can, understand what I'm talking about, you'll see what we look at on Thursday. All right, guys. All right. So once again, like I said, if you're not moving forward, then you're already behind. Bam. Well, I hope everybody's doing great, guys. Like I said, just keep at it. Keep helping around the house. Be nice at home, especially with everything that's going on. All right. Isaac, will we get home play over the break? No, actually, I'm actually gonna have you guys take a little break because we need a break. But we'll talk more about that on Thursday. Okay. All right, guys. Well, if anything, just send me an email, or in the Nearpod code, just make sure you write me any questions on some of the problems that you found. But I'm pretty sure it's going to be fairly easy to transfer what we just did today. All right, guys. Once again, love you guys. Keep at it. All right. And I'm still working on that playlist so I can send that out. I don't know. I'm thinking it's mainly going to be through my Google Drive, and I'll just give access for you guys to look at the playlist and hear some of them, and then we'll figure out the rest. All right, guys, have a good one. See you guys Thursday. Sorry. Peace.